We now turn our attention to the problem of early word acquisition, how very young children in their first months of life start to go from experiencing the linguistic input as, say it's spoken linguistic input, as a continuous unbroken stream of sound to something more like a sequence of units that are strung together one after another with implicit boundaries between each other, even though those boundaries are not manifest in the signal itself. We might call these units words. In the 1990s, there was seminal work that was done using very clever methods in the experimental child language development literature that led to a view that statistical learning was an important component of how young children break into their first language. By statistical learning, we mean that young children attend to the distributional properties of the linguistic environment, the statistics of it, and use those statistics to guide inferences about what the likely units are that underlie the language. To give you a sense of how this is experimentally studied, I'm going to play for you an example stimulus from this classic study and see what you think for yourself, see what patterns you detect. In this kind of study, the infant is brought into the lab, played a short recording, and then parts of the recording are played back to it. And depending on the different part, it may elicit different kinds of responses from the infant. So this is going to be about a 1-minute sample stimulus. It's pretty monotonous, but close your eyes and focus on it and see what you detect. Here we go.
Pabi kuti budo daro pi pabi kuti budo go latu ti budo daro pi pabi ku go latu daro pi ti budo go latu daro pi ti budo pabi ku daro pi go latu ti budo pabi ku go latu pabi ku daro pi go latu ti budo daro pi pabi ku ti budo go latu daro pi ti budo pabi ku daro pi ti budo pabi ku daro pi go latu ti budo go latu daro pi pabi ku go latu ti budo daro pi go latu pabi ku go latu pabi ku go latu daro pt budo go latu daro p pabi ku daro p pabi ku ti budo pabi ku go latu ti budo daro p go latu pabi ku ti budo daro pt budo go latu pabi ku daro p go latu ti budo pabi ku ti budo go latu pabi ku daro pt budo pabi ku daro pt budo pabi ku go latu daro p go latu ti budo daro p go latu daro p pabi ku go latu pabi ku ti budo daro p pabi ku ti budo go latu.
Okay, now I'm going to show you 4 candidate words from that input. So that was just an unbroken sequence of syllables. 2 of them are what we might call words from the input on a basis that I will explain to you in a moment, and 2 of them are not. So let's see what your gut instinct is about which of the 2 are words. Here are the 4. Pigola, golatu, daropi, and tudaro. So the ones that are quote unquote words are golatu and daropi. And although it's a noisy process and you may not have guessed both of those words, that may not have been your instinct, that actually was the tendency for the young infants in this, this study. And that was actually predicted by the researchers in the lead up to this study. So I want to explain to you now, how would we know what the infant would judge from a 1-minute clip like that? There's a wonderful YouTube video that I encourage you to check out. The URL is at the bottom right, but I'm going to give you just a brief overview of this, less comprehensive than the YouTube video that I'm referring to. So this is studied using what's called the head-turn preference procedure. In the head-turn preference procedure, the infant is brought in by its caregiver, as you can see on the right, sitting in a chair, and from the viewpoint of the infant and the caregiver, there are 3 sort of holes in the room, in the walls of the room. So the first one right here is one that, if you look at this viewpoint, this is the above viewpoint, there's an experimenter behind that viewing hole, and there's a video recorder that's video recording the scene. Additionally, there's a little light here that will go off. It's a green light that can attract the infant's attention. During this time, the caregiver has glasses opaque on that are blinding the caregiver. So the caregiver doesn't know what's going on in the room, and also has headphones that prevent the caregiver from listening to what's going on. So the caregiver is simply there to keep the infant calm. At the same time, there are also speakers on the left and the right sides, and there are red lights at those speakers. The lights can flash, and that will attract the infant's attention. At the beginning of each experimental trial, the infant will be played that long 1-minute clip while the green light in the center hole is flashing, that will, initially it'll catch the infant's gaze, and then the infant will, during that time, be habituated to the clip. After that, the experimental test phase begins. And during the test phase, what happens first is the green light blinks in the center. That attracts the infant's attention. And then one of the two speakers plays the short snippet. And that'll either be a word or a non-word from the input. So it might be Daropi. So for example, the speaker on the left might repeat over and over again, Daropi, 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 Daropi. And the infant will look at that because the infant looks at things that make sound. When the infant looks at the speaker, the red light starts flashing. That continues to hold the infant's gaze. And that'll continue until basically the infant gets bored and looks away. When the infant looks away, that ends the test trial. And the dependent measure is the duration of looking at that at that speaker with the flashing light during the test trial. And in this particular experiment, the finding is that words, things that have the property of being words, with respect to the artificial language input, the infant looks at words longer than non-words. And that discrepancy between two types of inputs during the test phase demonstrates that the inputs are treated differently by the infant, depending on whether they're word or non-word inputs. However, it turns out that of the four types of, the four characteristic inputs that I showed you, two of them were words, two of them were non-words, all of them have the same overall frequency in the input, okay? So they can have the same frequency in the input, but there is a distinctive property of them that will distinguish them, and we'll get to what that is in a moment.